been able to do up to 64 from the problem set. Let's start with questions from there. Max. 59. All right, so it just wants us to do the quotient. So in trigonometric form, that's going to be R1 divided by R2 times the cosine of theta 1 minus theta 2 so 3/14 times cosine of negative 150, I think, if I did that arithmetic right. And the directions ask for in trigonometric form, so that's all she needs. Yeah, Ryan? 25? Sure. So we're just getting this into trigonometric form. So the R is 6 squared plus 8 squared. So 36 plus 64 is 100. So the square root of that is 10. And then if I draw my theta, so theta is going to be, since it's in the first quadrant, it's just going to be the tan inverse of 8/6. And I think, oops, hey, come on now. Computer. Any time? Oh, great googly moogly. Come on now. It should be wired. Okay. And I think the problem asks for this in radians. So when I type this into my calculator, I want to make sure I'm in radian mode. So 0.93. So we have 10 times cosine of 0.93 plus I sine 0.93. Is that okay, Ryan? And again, I didn't have to do anything adjusting to that because I was in the first quadrant, right? If the point or that number was in a different quadrant, we might have to add or subtract 180 or 360 or whatever. Josie. 48. Yep. So it just is doing division. So to divide two complex numbers in standard form, I'm going to multiply the top and bottom by the conjugate. So when I FOIL that top out, I get 2 plus 2i root 3 minus 3i minus 3 root 3i squared all over 1 plus 3. So from here, I'm just going to combine like terms. Remember that I squared is -1. So the stuff without the i's, I have a 2, and then I have a positive 3 root 3. So put that all over 4. That's like my 8. And then the stuff with the i's, I have a 2 root 3 minus 3 all over 4. I'll stick an I at the end. So in standard form, there's my a plus bi, right? Now the a and b are kind of ugly, but that's fine. They've got irrational numbers in them, but that's an exact answer, which I... Yeah, it says exact is why I left it. If it didn't specify exact, you could have turned it into a decimal on your calculator, and that would be appropriate. But here the directions ask for an exact answer, so I don't want to do any rounding. Yeah, no problem. Anybody else? Okay. Today, let's get her done. The last section in chapter 11 is section 3. So here we're going to be talking about powers and roots of complex numbers. So we're going to start with powers first. So let's just say I have some complex number in trigonometric form. And let's say I want to figure out what z squared is. Well, I know that z squared is really just z times z. So using my multiplication rule from the last section, I'd have r times r, or r squared, times cosine of theta plus theta, so 2 theta, I sine 2 theta. Okay. Well, let's keep going and start looking for a pattern here. So z to the third, I'm going to think about as z times z squared. So again, if I follow my multiplication pattern, I have r times r squared, or r to the third, and then times cosine of theta plus 2 theta, so 3 theta, I sine 3 theta. And at this point, I think I see the pattern. Anybody else see it? I hope so. We'd say z to the n is equal to what? R to the n times, yeah, that's an n, cosine of n theta. Yeah, plus I sine n theta. Well, that's really convenient. This has a name. This is called Demovrey's theorem. He's a French mathematician from way back in the day. And we can see here this would be an enormous time saver as opposed to what we'd have to do in standard form, right? What would we have to do in standard form? Like a terrible binomial expansion. Like if I had 5 plus 2i to the 10th, I'd have to multiply 5 plus 2i times 5 plus 2i times 5 plus 2i plus 5, like 10 of those, which is a lot of foiling and like a colossal pain in the tuchus. Or you could use like the binomial expansion theorem that we would have talked about maybe the end of last year in your Algebra 2 class. I don't even remember if we got that far, but it's a way to expand a polynomial or binomial using combinations. Anyways, it stinks. That's the point of the matter. What would be easier? Put it into trigonometric form and use this, right? Let's do a quick example to just kind of hammer this home. So let's say we have 5 times sine of 14 plus cosine of 14 plus I sine 14 to the 5th. What do I get? Using Demovrey's theorem, we have well, let's write as 5 to the 5th first, but that is what, when you type that into calculator, what we get. Yep, and then we have cosine of 5 times 14. And again, if you wanted to, that's, well, we'd want to write that as 70, right? Plus I sine 5 times 14. So there's our trigonometric form. Or if we were so inclined, we could type that stuff into the calculator. So 3,125 times cosine of 70 is this. And then 3,125 times I sine 70 is this. So depending on what the instructions were, your answer would be one of those two fellas. Again, depending on whether they are asking for a trigonometric answer or a standard form answer, right? You don't have to do both of them, just whatever the directions would say. Cool! Demovrey's theorem makes life pretty easy. Easy to remember, easy to use, easy, easy, easy. Great. Any questions about that? No, man, it's easy. Okay. Roots. Well, let's again say we have a trigonometric form, complex number. So r times cosine theta, I sine theta. And we want, say, the nth root of that number. Well, if I remember back to Algebra 2, I can rewrite the nth root as an exponent. What exponent is the nth root the same as? 1 over n, very good. And hey, that's an exponent. So now I can just use Demovrey's theorem, right? 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 No. Not quite. What's the issue here? The issue is that coterminal angles come into play. So really what we have, I'm going to rewrite the nth root, or r to the 1 over n as the nth root of r, since this is going to be the formula. Or if you prefer radians, we could just change those 360s to what? 2 pi's. So what is this really saying here? How many answers should I be getting for an nth root of a complex number? N answers. Right? If I count 0 to n minus 1, that's n numbers. If I count 0 to 4, that's 5. Right? 0, 1, 2, 3, 4. Everybody's cool? Let's see this in motion now. Again, not too bad of a formula, right? Even as formulas go. It's basically Demovrey's theorem, but we have like a couple of extra answers that we have to run into, but whatevs, not a big deal. So let's say we want the cube root of 3 minus 2i. Okay. First thing I should do here is, I got to get that complex number into trigonometric form because I do not want to do this in standard form because it is not pleasant. So r is 13. 3 negative 2 is here. So there's my theta. So theta is going to be 360 minus the tan inverse of the absolute value of negative 2 over 3. And I'm going to choose to use degrees here just because, I don't know, because it seems like it's more familiar for most of us. You know what I mean, guys? Maybe some of you guys are radian hogs. I don't know. Degrees always feel a little bit more natural. So 326.31. So there's my conversion to trigonometric form. No big deal there, right? Feels like that's a process we've done about 3 or 4 times throughout different chapters over the course of this course. Should be getting pretty good at this by now, you know what I mean, guys? All right. So then if I want the cube root of this, I'm going to do the cube root of r. So I have the cube root of the square root of 13. That looks pretty gross. Times cosine of 326.31 plus 360k over 3 plus I sine 326.31 plus 360k over 3 for k equals 1, 2, or 0, 1, 2. Any questions how I got to here? Okay. Well, all that's left is to grind out these 3 answers. So I'm going to have 3 answers, one for k equals 0, one for k equals 1, and one for k equals 2. Everybody feel all right there? Good. All right, so the cube root of the square root of 13 is just the 6th root of 13. Always. What's the n for a cube root? 3. N is the index of the radical. So 0, 1, 2, and that's n minus 1, so I'm done. Is that cool? Yeah. Okay. So the cube root of the square root of 13 is the 6th root. Wait, what? Well, remember, square root is what exponent? 1/2. The cube root is what exponent? 1/3. And when you have an exponent of an exponent, you multiply. So that's a 1/6, which is just the 6th root. Is that cool? Again, algebra 2. It's important. When k is 0, I just end up with 326 over 3. Oops. 6. Oh, let's just do that. So 108.77. When k equals 1, I'm going to take 326 plus 360 divide by 3. So that's going to be cosine 228.77. And when k equals 2, we're going to have 326 plus 720. So 348.77. Everybody's okay with that? What would happen if I accidentally did k equals 3? So that is 1080. So I'd have 326 plus 1080 divided by 3. What do you notice about 468.77? It is coterminal to 108.77. You guys see that? So if you accidentally do too many, you're just going to get an answer that you already got. Oh! And you know what the real talk here is? Do I specifically need 0, 1, and 2? Any 3 consecutive integers will work. Will they be in a different order? Yeah. Could their trigonometric form look different? Yeah. But is it equivalent to the same standard form number? Yeah. So who really cares, right? Not me. So once we have these trigonometric form answers, if we wanted a standard form answer, I would do the 6th root of 13. Reminder to type a 6th root in your calculator. You can type the number 6. Press the math button and go to the command 5, the one with the xth root on it. So there's my 6th root of 13. And I do cosine of, well, let's do the last one because it's the easiest to get to the angle. So 1.50. And then do the same thing with a sine. Negative 0.30 and stick an I at the end. So again, these would be our trigonometric form answers, and these would be standard form answers. Depending on what the question was asking for, you might answer either of these could be acceptable. Just depends on the direction. Not too bad, right? Means a little bit of writing or whatever, but like it's easy writing, you know. We're not doing anything like super complicated, keeping track of like crazy stuff and making weird decisions. I'm just following a formula. The formula has a lot of parts to it, but like, you know, it's not that complicated. Let's do one more example and we'll call her quits. Sound good? So let's say I want the 4th root of 16. Well, what's that? Fourth root of 16? 2. Incomplete answer. How many answers should you get? 4. Because it's a 4th root. I should have 4 answers. Whoa, Mr. Kulik, where are those 4 answers coming from? Let me show you. So we're going to convert this into a trigonometric form. Hopefully it's easy to see when I draw the picture that r is 16 and theta 0. Yes?
It's kind of random, but for graphing complex numbers, there's like no calculator.
Correct.
Okay, you do that.
Correct. Yeah. Yeah. I do not know of one anyways. Maybe it's possible. I don't know about it. Everybody's cool? So far, so good? So 16 is just 16 times cosine 0 plus I sine 0. So the 4th root of 16 is going to be the 4th root of 16 times cosine of 0 plus 360k over 4 plus I sine 0 plus 360k over 4, where k equals 0, 1, 2, and 3. Everybody's cool with how I filled in my formula?
The extra 16 roughly.
You're asking this one?
Well, that's the R.
That's the R.
But why is there like that same thing as Z?
Well, we're asking for the 4th root of 16, right? The 4th root of 16 is that stuff. Is that, I was just kind of writing the question.
Yeah.
Since before that I had just 16 in trigonometric form. We're cool though?
Yeah.
Okay. So we're going to have 4 answers, right? So when k equals 0, I have the 4th root of 16, that's just 2, times cosine 0 plus I sine 0. Cosine of 0 is 1. Sine of 0 is 0. So this just becomes 2. There's the first answer. When k equals 1, I have 360 over 4, so 90 degrees. Cosine of 90 is 1. Sine of 90 is 0. Oh, I'm sorry, other way around. Cosine 90 is 0, sine of 90 is 1. Yeep! So I have 2i. Sorry, guys. When k is 2, I have 720 over 4. That's reduces to 180 degrees. Cosine of 180 is negative 1. Sine 180 is positive 0. I don't know why I put positive there. So that gives me negative 2. And then when k is 3, I have 1080. 1080 divided by 4 is 270. Cosine of 270 is 0. Sine of 270 is negative 1. So those are my 4 answers. These are my standard form answers. These would be my trigonometric form answers, depending on what the question asked for. You might report your answer in either way. Okie dokies. Right on, my dudes. Yeah, so that's it, right? Not too bad. I think this is kind of the most complicated thing you have to do is these roots, but even there, you're just kind of like grinding through a formula, and they're not that complicated. So that's the good news. The bad news is now you should be able to do 65 through yikes. So this closed chapter 11. Next time we'll do the review day, and then the following class we'll have the test. So I think that's Monday for you guys. But it's good. We'll get that done before we go on spring break, right? Potentially. Megan?
So for people helping the federation that will not be here, what would you like?
I mean, ideally, it'd be great if you could find a way to make that up before spring break. Either testing room or study hall is okay with me. If you send me an email telling me which one you'd like to do, that'd be great. If you can't get it done before spring break, that's less than optimal, but we'll deal with it after spring break as best we can.
Okay, thank you.
Yeah, no problem. All right. As you guys have probably already heard, what am I going to ask you to do now? Yeah, homework quiz time. Everybody's can't keep the cat in the bag on these things. Maybe next time I'll give it to the B day before I give it to the A.
That'd be so toxic.
Right?
Please don't do that.
Why not?
Because I always like fail because I don't like, I have to figure stuff out before.
Well, maybe you deserve to fail once in a while.
Yeah.
The person from A day deserves to pass for once.
Yeah, you know, they'll be okay.
No?
Well, I mean, you gotta draw my quiz eventually. And I'm doing okay. So I couldn't fail it.
Remind me, possibly taking it just next class. Why? Because it was Is that just re-gone? No, I just had it stuck. Oh. I'd be more inclined to just like we did a bunch of review. I feel like I got the fine. Yeah. I think I'd rather have you do it now. While you guys are working, I'm going to just talk for a minute. So seniors, you guys are nearing the end here, getting pretty close. Over spring break, in preparation for the end, I'll be putting in the drops for homework quizzes and homework assignments. Now, unfortunately, I can't do that individually, so it happens for everybody all at once. So everyone over spring break will see their grade change because of the drops going on to the homework quiz and the homework assignments. Reminder that on your end, you can't tell what the computer is counting as your dropped scores. You'll still be able to see all your scores on the online. Trust me, the computer is doing it correctly, that it's identifying the low scores to drop. Juniors who will continue to turn in homework assignments and homework quizzes and stuff, I promise you, every time a new score gets entered, the computer retabulates the lows and adjusts what's being dropped. So you don't have to do anything. I don't have to do anything. There's nothing to do. It just, the computer will automatically do it as soon as a new grade is entered instantaneously. You'll never see like with the new grade in and then have to adjust. It'll just happen automatically. Seniors, when you get back from spring break, I'll have information for you about the final exam and an exam review. At that time, we'll also need to figure out if you wanted to do the doubled high test score or retake. Juniors, we'll wait and make that decision for you until all the tests have been taken. Seniors, the Chapter 11 test will be the last test you take other than the final. Anything we cover after Chapter 11 would be exam-only stuff. So even if we get to another test before that, I don't think we would, but if we did, you would not be responsible for it. I think that covers it. Okay, cool. Anyways, I just wanted to say all that jazz. Have I said that already to you guys? I did? Oh, well, here's my friend Pete.